Hello again, everyone. Mr. Cruze here with another Algebra 2 review for you. This week's edition is Chapter 9 test review. Okay. Remember, Chapter 9 was a relatively short chapter, and there are really only 4 topics, and they're right on the screen in front of you right now. We basically talked about arithmetic and geometric sequences and series. Okay. There were 4 formulas that you needed to use. Remember, arithmetic was if you were adding the same number every time. Okay, adding the same number every time. Geometric was multiplying by the same number every time. Okay. In addition, adding is the same as subtracting, so if you're subtracting the same number, that would be arithmetic. Same with multiplying. Multiplying is the same as dividing. Okay. But anyway, these are the formulas. I suggest you just write these down in your review. It might help you study them and keep them organized. But basically, if there's any questions about these formulas, you can always Twitter me, email me, post a comment on this video, whatever it takes, okay? I will also be here in the morning at school. So, let's try some out. What do you say? Put your name on it, of course. Number 1 through, let's see, what is this, 1 through 6? Just ask you to determine whether the sequence is arithmetic, geometric, or neither, and if it is, tell me what the common difference is or the common ratio, okay? So we're going to see if we're adding the same number, multiplying by the same number, or neither. Okay. To get from 3 to 7, I'd have to multiply by a wonky number, so we'll try adding first. I know I add 4. To get from 7 to 11, I'm adding 4. And to get from 11 to 15, I'm adding 4. Since these are all the same, it has to be arithmetic. And what is the common difference? It's 4. Took us literally 5 seconds to do that problem. Number 2. If I were adding, to go from 100 to 10, I would subtract 90, but to go from 10 to 1, I'd subtract 9. There's no way that's adding the same number. So it's not arithmetic. Could be geometric. Let's see. Basically, if I take a term divided by the previous term, I should get the same number every time. So 10 divided by 100 is 1/10. 1 divided by 10 is obviously 1/10. 0.1 divided by 1, quick calculating on your calculator, gives you 1/10 as well. Okay? Since they're all 3 the same and you're multiplying by 1/10 every time, it's geometric. What's R? R is 1/10. Remember, D goes with arithmetic, R goes with geometric. Okay? Number 3, let's look for adding first. 25 to 50, you would add 25. 50 to 75, you would add 25 as well. And 75 to 100, you'd add 25 again. You're adding 25 every single time, so it has to be arithmetic. Okay. And since it's arithmetic, that means D equals 25. Okay. Number 4, looking here, to get from 1 to negative 2, you would subtract 3. To get from negative 2 to 4, you would add 6. Oh, so there's no way it's arithmetic. Geometric, to go from negative 2 to 1, you'd have to, or from 1 to negative 2, you'd have to multiply by negative 2. To get from negative 2 to 4, you'd multiply by negative 2. But to get from 8 to 4, you multiply by positive 2. Are they the same every time? And they might be this tricky. They're not the same, so this is neither. It's not arithmetic or geometric. Okay, so be careful. Be on the lookout. Number 5, let's see. To get from 18 to negative 6, you would have to subtract, what, 24? But to get from negative 6 to 2, you'd have to add 8, so there's no way it's arithmetic. Probably as evidenced by the fraction. Let's try geometric. Negative 6 over 18 is negative 1/3. 2 over negative 6 is negative 1/3. Negative 2/3 divided by 2, a quick check on your calculator should tell you it's negative 1/3 as well. So yes, this is geometric. You're multiplying by 1/3 every time, or negative 1/3 rather. Okay. Number 6, let's see, 1 to 1/2, you would subtract a half. 1/2 to 1/3, you would, oh gosh, subtract what? 1/6? Oh, so they're not the same. Okay, multiplying, well, let's see, 1/2 divided by 1 is 1/2. 1/3 divided by 1/2 is actually 2/3. Okay, not the same. So this is neither again. Be on the lookout, okay? To test if it's geometric, take a term divided by the previous term and continue doing that and make sure they're all the same. Okay? Find the 32nd term of the sequence. Alright, so 9 to 4 to -1 to -6. That's clearly arithmetic. You're subtracting 5 each time, right? So the arithmetic sequence, I go back to the beginning. It's this formula. Okay. I want the 32nd term. So I take the first term, which is 9, plus the common difference, which is -5. So I'm going to put that in parentheses there. N minus 1. Well, n is 32. That's the number of term I'm trying to find. So this will equal 9 plus -5 times whatever that is, which would be 31. 9 plus what's -5 times 31? Well, quick plug in your calculator gets you -155. And 9 plus a -155 gets you -146. I want to make this very clear. If you sit here on your test tomorrow and you actually just keep subtracting 5 until you get to the 32nd term, you will not finish this test. Okay? You have to use these formulas as shortcuts. I promise you. Alright? Find the missing term of the arithmetic sequence. Well, to find the missing term of an arithmetic sequence, you take the two terms around it and find their average. Okay? The formula looks something like this on your test. And this formula will be on there. You basically take the previous term plus the next term and divide by 2. So I take 5 plus 21, divide by 2. So it'll be 13. Check. And you can always check it. 5 plus 8 gives you 13, plus another 8 would give you 21. Okay? Take a look at number 9. It's the exact same. Find the arithmetic mean. They might as well be asking you, what's the missing term, right? So we're going to add these and divide by 2. You get 2.2 divided by 2, so you get 1.1. Pretty simple. Number 10, find the missing term of the geometric sequence. So we're going to have to use geometric mean, which means here's your formula for that. Plus or minus the square root of an minus 1 times an plus 1. Okay. Again, it'll be on there. So I can go ahead and put plus or minus, because I know no matter what, it's already going to have plus or minus, okay? So I'm going to take plus or minus the square root of 5 times 911.25. We'll see what we get. 5 times 911.25 is 4556.25. And when you take the square root of that, you get 67.5. So that's what you put. Okay. 11, same way. Geometric mean, so it has to be multiplied and then take the square root. So you go ahead and punch that in your calculator, 9180 times 255, and you get, big number, 2,340,900. That's okay, that's what calculators are for. Let's take the square root of it, hopefully it comes out nice, and it does. 1,530. Just make sure you have the plus or minus, okay? If this were a multiple choice question, they may or may not have the plus or minus on there, all right? Remember, geometric, you kind of need the plus or minus because you don't know. It could be the positive one or it could be the negative one, okay? Let's continue on. Write an explicit formula for the sequence, then find the fifth term in the sequence. So A1 is 100, R is -20. Well, that R tells me it's already geometric. So the geometric explicit formula is this. So I can find any term in the sequence. A1 is 100, R is -20 to the n minus 1. This will be worth part of it. Okay, you've already got half of the answer. Do not plug in n. Not yet. Okay, it says write an explicit formula for the sequence. So we want any term. Then find the fifth term. So then we'll plug in 5. Okay? We're not going to worry about it until after we get the equation. Because then I could ask you any term in the sequence, right? Let's see. All you have to do is be very, very careful. Make sure when you type -20 to the fourth that you put parentheses around the -20. Okay? If you don't, you're going to be in trouble because you'll get a negative answer. Anyway, 100 times 160,000 will be a nice, cool 16 million for your answer. Just make sure you have the appropriate number of zeros there. Okay? Not so bad, right? The following sequences have 8 terms. Evaluate each related series. We just need to know is it geometric or arithmetic, right? Well, 1 to -1, I would have to subtract 2. I would have to subtract 2 again, so this has to be arithmetic. There's no other way. Otherwise, I'd be multiplying by -1. Well, that wouldn't get anywhere, okay? So arithmetic. Well, an arithmetic series is this. N over 2 times the first term plus the last term. Do I know what n is? Yes, I do. It's right there. They're telling us -13 is the 8th term. So n is 8. What's the first term? 1. What's the last term? -13. So let's go ahead and figure it out. S8 is 4 times, what's 1 plus -13? Well, that's -12. So your 8th term is -48. Pretty simple. 14, same thing. We still know n is 8, but this time, what are we? Oh, we're adding 8 again. We're adding the same number every time. So arithmetic again. Same formula. That's nice of them. 8 terms again. How do I know that? Because the instructions tell me. 5 plus, this time the last term is 61. So let's see, S8 equals 4 times 66, which, if I'm not mistaken, will be 264. Good. That's the sum. If I were to take 5 plus 13 plus 21 plus 29, I mean, I almost want to do a video where I show you guys how terribly long this would take. And you can clearly see 61 is the 8th term. 1, 2, 3, 4, 5, 6, 7, 8. You could plug all those in your calculator. You could certainly go 5 plus 13 plus 21, but it would all take too long. You will not finish the test if you're going to do that the entire time. Okay? Much, much simpler to use these formulas. All right? I'll get off my soapbox for now. Join me in the next video. It should be linked below. If you have any questions or comments or anything, you could always subscribe and post on here, or you could post on my Twitter at Mr. Cruze Math, or you can certainly email me ccruze@brownsburg.k12.in.us, and I will be glad to help you. All right? Good luck studying.